The signal that just reached Earth left Voyager 1 almost a full day ago. For nearly 23 hours, it traveled alone through the darkness, crossing more than 24 billion kilometers of empty space before finally reaching the antennas of NASA's Deep Space Network. And when it arrived, it carried something we still cannot fully explain. Voyager 1 is not a modern spacecraft. It is not a giant observatory, nor is it equipped with today's powerful computers, artificial intelligence, or advanced propulsion systems. It is a small machine built in the 1970s, running on a weakening power source, and using technology older than almost everyone watching this video. It was supposed to last only 5 years, yet it has survived for nearly 50. Now, from beyond the edge of the solar system, in a region no human eye has ever seen and no other spacecraft has explored in this way, Voyager 1 is detecting something strange, a faint, persistent hum in interstellar space. This is not a brief burst, a random glitch, or a single corrupted reading that can be dismissed and forgotten. It is a continuous signal stretching across years and hundreds of millions of kilometers, coming from the plasma that fills the space between the stars. And that is only the beginning. Voyager 1 also discovered a blazing, violent boundary at the edge of our solar system, where scientists had expected a much smoother transition. It even survived a failure caused by a single tiny memory chip that nearly ended one of the most important scientific missions in human history. Yet soon, this remarkable spacecraft will fall silent forever. When that day comes, we may lose the only instrument humanity has inside the space between the stars. So the question is not simply what Voyager 1 detected. The real question is this: are we paying attention before the signal disappears? Voyager 1 launched from Florida on September 5, 1977. At the time, its mission sounded ambitious, but compared with what it eventually became, it was almost simple. The plan was to fly past Jupiter, then Saturn, collect measurements, capture images, transmit the data back to Earth, and eventually fade into history. It was expected to spend only a few years exploring the outer planets, sending humanity a scientific postcard from the edge of the solar system. But Voyager 1 did not stop. In 1979, it reached Jupiter and revealed a giant world of immense storms, intense radiation, powerful magnetic fields, and fascinating moons that proved far more complex than anyone had imagined. Then, in 1980, it passed Saturn, returning extraordinary data about the ringed planet and its mysterious system of moons. Each encounter used gravity like a giant slingshot. Jupiter accelerated the spacecraft, and Saturn pushed it even farther into deep space. After those encounters, Voyager 1 was no longer just a planetary probe. It became humanity's first messenger to interstellar space. For decades, the spacecraft continued moving outward, traveling beyond the planets, beyond the familiar structure of the solar system, and beyond the region where the sun's influence dominates everything. Then, in 2012, Voyager 1 crossed the heliopause, the true boundary of the solar system. This is not where the planets end, but where the solar wind finally loses its strength and the environment of interstellar space begins. Beyond that invisible line, the spacecraft entered a region filled with ancient plasma, particles released by stars that lived and died long before our own sun was born. Think about that for a moment. Right now, Voyager 1 is not simply far away. It is traveling through a medium that no human civilization had ever directly touched before. And from that extraordinary location, it is still speaking to us. But the message is not as simple as scientists once expected, because the data returning from Voyager 1 does not match the quiet, predictable picture they had imagined. The space between the stars was once thought to be thin, cold, and relatively uniform. Instead, Voyager 1 discovered something much more active, more structured, and more dynamic in a physical sense. That discovery began with an unexpected sound. Since 2017, Voyager 1's plasma wave instrument has been detecting a strange emission in interstellar space, a faint, narrow, persistent hum. It is not the aftermath of a dramatic explosion, not a shock wave from a solar event, and not a random spike in the data. It is a steady signal that has continued year after year, remaining quiet, thin, and constant, like a low vibration flowing through the plasma between the stars. This matters because scientists expected interstellar space to be much calmer than this. It was never believed to be completely empty, but they expected it to be smoother, less textured, and less variable, a place where changes in density would be almost impossible to observe unless major events disturbed the region. Voyager 1 revealed something entirely different. The interstellar medium is not a perfectly silent ocean. It possesses structure. It contains fluctuations in density. It experiences turbulence, and those conditions change over distance. Voyager 1 is moving through this environment in real time, measuring physical conditions that no other spacecraft has ever observed from within. That is why the mysterious hum is so important. It gives scientists a way to continuously map the density of interstellar plasma instead of waiting for rare solar eruptions to create stronger signals. In many ways, it is like listening to the background vibration of the galaxy itself, a faint tone that reveals the space between the stars is not dead. It is not the smooth, empty void we once imagined. It is active, restless, and constantly changing. The strangest part is that scientists still do not fully agree on the exact physical cause of the emission. One possibility is that the hum is produced by natural plasma vibrations interacting with the surrounding environment. Another is that it comes from the random motion of electrons, revealing hidden information about the true density of the interstellar medium. Both explanations are scientifically valid, and both are taken seriously. Yet neither changes the larger conclusion. Voyager 1 has shown that the vast space between the stars is far more complex, dynamic, and mysterious than anyone expected.